Okay, this is the ProsKit MT5210 LCR meter. Okay, and I have it set at the 2 mHenry range, the lowest range that it's capable of. And here are the leads, short leads, as approved. So what I'm going to do first is just hook these leads together. If I can do this with one hand. There. Whoops. There. Okay, so those leads are hooked together, and we'll give the instrument a moment to stabilize. Okay, that's good. So the meter is telling us that it is reading 1 microhenry of inductance from these leads together, between 0 and 1 microhenry. Okay, so let me do this little trick here. Let's switch the range up, and then, whoops, and then back down. And let it go through its thing again. So 1, and then maybe after a little while it might drop down to 0, which is telling us that it's somewhere close to 1 microhenry of inductance in the leads alone. 1 microhenry is, of course, 1,000 nanohenries. Okay, so now let's unclip that, and here's a little commercial stock inductor that I found in my box, and it's marked can you see that? 1.5 mHenry, right? That's an M next to the H there. 1.5 mHenry is the marked value of this little inductor. Okay. So let's go ahead and see what the ProsKit says. Let's hook that there, and hook that there. Okay, so the ProsKit meter is giving us a value of 1.519, or really, since the leads are part of that inductance, 1.518 mHenries for this inductor that's marked 1.5 mHenries. So, I mean, that's within the component tolerance. That's accurate, right? Okay. But the real problem with inductances is measuring very small inductances, right? So here I have my row of little brown inductors with the white dot. These are 1 microhenry inductors, each one. So let's go ahead and hook up one on the end. Okay. Oh, the meter just fell off the table. Okay. So anyway, one of those little inductors is hooked up. And remember, we have 1 microhenry of lead inductance. So the meter's showing us 2 microhenries total, or 1 microhenry for the actual inductor itself. Okay. So let's go down one. Sorry about that. Okay, so now we have 2 of the series inductors hooked together. And the meter now says 3 microhenries, between 2 and 3 microhenries, something like that, taking into account the lead inductance. Okay, so now I go to 3 microhenries. 1, 2, 3 inductors in series. Okay. Okay, 4 in series. And 5 in series. Now these components have some tolerance to them. That is, they're not going to be exactly 1 microhenry each, and there is some inductance in the leads, somewhere around but a little bit under 1 microhenry. Okay, that's 5 in series, 6 in series, 1, 2, 3, 4, 5, 6 in series. And 7 in series. Right? Okay. Now, the Tar Baby and the Ainslie circuit both use 4 of these 1 ohm 10 watt so-called concrete or sand or ceramic resistors in parallel to monitor the current. This is the so-called shunt or current viewing resistor, all in parallel to give a value of 0.25 ohms. Here I've got one just like that. So now we're going to measure its inductance. Okay, so we'll use the shortest bit of leads possible. Clip it right up close to the body. Okay, I'm going to say that resistor has an inductance of 7 microhenries. 7 microhenries. Okay, and there's 4 of them in parallel. So I think we can do the math. 1 over the total inductance is equal to 1 over the inductance of each individual resistor added up together. The individual resistors are 7 microhenries each. And let's just do a little recheck, reality check here again. Where's that commercial inductor of 1.5 millihenries? This resistor has an inductance of 7 microhenries. Thanks for watching.